Welcome to Zero Knowledge. I'm your host, Anna Rose. In this podcast, we will be exploring the latest in zero-knowledge research and the decentralized web, as well as new paradigms that promise to change the way we interact and transact online. This week, I dive into the Mina project with CTO Brandon Case and Head of Product Steve Pack from o1 Labs, the team building Mina. We chat about how their journey led them to work on Mina, how Mina has developed since we last did an episode with members of the team, the zkApps building environment, o1js and the philosophy behind it, and what use cases we may see on the horizon, especially as we see zk move from being more research-centric to builder-centric as an ecosystem. Now, before we kick off, I just want to remind you to check out the zk jobs board. There you can find jobs posted from top teams working in zk, as well as deeply technical teams like Gnosis, Zama, Alio, and more. If you're looking for a new job opportunity in zk or in adjacent technologies, be sure to check out the zk jobs board. I've added the link in the show notes. Now, Tanya will share a little bit about this week's sponsor.
Near, the OS for an open web, and Polygon, the leading Ethereum Layer 2 scaling solution, are teaming up. Near Foundation and Polygon Labs just announced from NearCon 23 that they will build zkWASM, a zero-knowledge zk prover for WASM blockchains. With Near's deep WASM runtime expertise and Polygon Labs' authority in zk scaling technology, the zkWASM prover will help create a more secure, interoperable Web3 ecosystem. Set for a 2024 launch, the zkWASM prover also positions Near protocol closer to Ethereum and enables WASM chains to tap Ethereum liquidity. In the near future, an interop layer will allow blockchains including Layer 1s, EVM Layer 2s, and WASM chains to share liquidity within a unified ecosystem. Leveraging zkWASM prover, WASM chains will settle transactions efficiently and securely, unlocking the full potential of zero knowledge for a multi-chain open web future. Stay up to date with the zkWASM announcement at near.org. So thanks again, Near. And now, here's our episode.
Today, I'm here with Brandon Case, CTO, and Steve Pack, Head of Product at o1 Labs. Welcome to the show.
Hello.
Hi, Anna.
Now, before we kick this off, I just want to mention that I'm an advisor to o1 Labs. It's actually been a couple of years. I get a chance to speak to both of you every 2 weeks, so it's really fun to have you on the show. And also, zk Validator is a validator on Mina as well. I feel like on the show, we've actually covered this project a number of times. Even like way back when the project was called Coda, we had Isaac and Evan on at the time. We did an episode all about the Mina snarkitecture with Isaac. And 2 years ago, we did an episode about snaps with Emre and Isaac. I'm going to add links to these in the show notes. Today's episode, I think, is very much taking from that last episode on snaps, which has been rebranded since then to zkApps, and kind of going forward with that. But before we do that, let's get to know both of you. Brandon, let's kick it off with you. You've been at o1 Labs for a really long time. Tell us a little bit about what got you started, how you got into it.
Yeah, so what got me started? Two things. Well, maybe three. One, I was really good friends with Evan Shapiro, one of the co-founders of o1 Labs, Mina Foundation, Mina Protocol. And we had built things together in university, so I knew that we worked well together. At the time, I was really excited about functional programming, software engineering in general, building engineering teams in a certain way. So when I talked to Evan and Izzy, I got really excited about the project. So I came in working nights and weekends originally in the fall of 2017. And then as soon as a long time ago.
So early. Was that, had the company even been founded then?
No.
Oh, wow.
No, the company was founded officially in January.
Okay.
So around my birthday. I remember it. And at the time we were building a JavaScript prototype of Mina, which we threw out and switched to OCaml. But yeah, in those early days, it was really exciting, really challenging. I personally had severe imposter syndrome. I had to review Isaac's code and, Izzy, the way that his brain works, it's very mathematical. He was working on a PhD in cryptography, which he stopped to work on this project. But even in his software that didn't touch the snarks, there was all this like algebraic geometry and all these weird very foreign concepts for me. And I had to work really hard to do, what I thought was like a good enough job.
Wow.
And yeah, for many months. So if anyone else is, just getting into zk, getting into crypto, like starting to work on really challenging projects, I would recommend just try and work through it, work really hard, and then
bite the bullet, accept the imposter syndrome, and just keep going.
Just keep going, yeah.
Yeah.
And eventually I got more sort of confident. So anyway, I started as one of the founding engineers, and I did so many different roles throughout the lifetime of the company, and now I'm CTO.
That's amazing. And actually, when we met, or when I first started coming on calls with you guys, I always got the impression that you had a bit more of like a DevRel or like a community focused role, because you had done those educational videos, you were at the events, evangelizing, helping developers. And so, yeah, I kind of wonder, how did you end up doing that for a period of time?
Yeah, so as I said, I started an engineering position, very focused on protocol engineering. All of us were focused on protocol engineering in the beginning. And it was really fun, really challenging. We quickly hired a bunch of extremely brilliant protocol engineers. And my role switched initially to like ramping those folks up.
Mm-hmm.
I felt that was the best way that I could add value to the project. And then once they were ramped up, I realized we need to be doing product engineering, or we need to think about product anyway. So we started looking for product management, and I started doing more as what you would call product engineering. We sort of grew that team. We grew a product engineering team. I became an engineering manager. Then we hired an engineering manager who's much better than me at managing engineers. And
it's like,
I realized,
Brandon, you keep creating jobs and then hire, but that's the dream, right? You create the job and then you hire someone to do it instead of you.
Right.
So you can do another thing. Okay.
Exactly.
Cool.
Yeah. And so DevRel, or this kind of, you can think of it, I guess you would call it DevRel, but I always really enjoyed and felt passionate about teaching. I still feel passionate about teaching, and teaching both to like super advanced technical audience. I love that. And I love trying to come up with ways to translate that technical information into a more consumable form for beginners, for technical and non-technical beginners. And you may have seen me on YouTube videos about Mina. People always like they point me out on the street.
They know you
about that. Yeah. And
You're
of course,
the Mina
like
guy.
yeah. The marketing team really helps me like cut that script. I was like going on crazy rants when we were filming those. Yeah. So anyway, I went through that, and I wore many different hats, and finally to the hat that I am now currently wearing.
Very cool. Steve, let's move on to you. You joined more recently, and you're head of product. Tell us a little bit about what you were doing before this.
Started my career, I was a software engineer. So 12 years writing code, mostly in finance, high frequency trading. Loved it, but always wanted to sort of scratch the entrepreneurial itch. And so after that, I started a company. It was funny hearing Brandon talk about university and school friends. So I started a company with a mate from high school. I'm Australian, by the way, hence if anyone was wondering about the accent. And we made Wi-Fi routers that let parents limit screen time for kids. And super successful, super fun, shipped 10,000 units, got onto the shelves of Target, but also learned hardware is hard and grinding out hardware margins is hard. And at this time I was living in Silicon Valley, and that entrepreneurial experience sort of taught me that as much as I loved coding, like to be able to sort of bring a team together and, build a product was even more exciting to me. And so, when the company wound down, I was set on product as my future career, and was fortunate enough to join Cloudflare in the very start of 2018. And really got to, cut my teeth on Web 2 product management and, building software at fast growing company, and learned everything imaginable about the infrastructure of the internet and, all that cool stuff. And like many, I've since learned that this is a common story in Web3. It's like during the day, you're doing your day job, and during the night, you're on crypto Twitter, or you're deploying Solidity apps, or you're testing out DeFi things. And that was my experience too. I just was drawn to this technology, and I dipped my toe in a few times actually over the years, but always came away sort of feeling like this stuff's really interesting, but it hasn't really got adoption yet. And it hasn't really proven the use cases yet. And each time I came back, it was like, okay, it's getting there. It was like, firstly, Bitcoin is a store of value. And then, okay, like, Ethereum is this global consensus layer where people can deploy smart contracts, and then DeFi, then NFTs, and, it just kept going. And so at some point I was like, okay, I want my passion to be my full-time job. And, started looking around, and the position was available at O1 Labs, and I really loved sort of the mission and the differentiating aspects of Mina, which I'm sure we'll dive into. And so, 6 months ago, joined head of product, and I guess my hope is to, bring some of those lessons learned from Web 2 and being in a sort of hyperscaling company and bring them to Web3 and, help us get crypto into the hands of the next billion users.
Yeah. Question about working at Cloudflare. Like, didn't they use ZK actually on some product? Like, there was some ZK thing. I remember reading about this years ago.
Yeah, it's kind of esoteric. So the actual Cloudflare has a research team that has a lot of crypto research. Yeah, that one you're talking about, I think that was zero knowledge proof that you had a hardware key from a certain set of manufacturers. Oh. And I can't remember exactly what that was, whether it was improving the score for bot mitigation, but it was sort of, Cloudflare's first use of zk. They also run an Ethereum gateway and an IPFS gateway. So there is, some crypto folks. Yeah.
Interesting. Actually, I remember I went to the office in 2019 and I saw that wall of lava lamps to create perfect randomness. And I had been doing it, like, I think an episode on VDFs right around then. So I remember like that connection. I was always actually hoping that a company like Cloudflare would jump into ZK or something more substantially. Do you think there's still a chance? I realize you're not there anymore, but I thought I'd ask.
Yeah. I don't have any inside info, but I think Cloudflare, for all of the like interesting technology, they are rightly like relentless and ruthless at building what customers want. And, they'll, take some risks, but, there needs to be, especially as a public company, a pretty high level of conviction to really invest heavily in something. So I don't doubt each new paper that comes out, each new technology comes out, like it's being looked at, especially by this research team, and, prototypes are being built. But, to get that into the hands of, the entire customer base, there's a few gates to clear there.
Makes sense. So you joined O1 Labs, but I think now would be a really good moment to introduce Mina to the audience. I feel like a lot of folks who are listening, given that, we've done these previous episodes, may be familiar with it. But why don't you just, for those who aren't, just share with us in short form, what is Mina?
Yeah, I'll give it a crack, and I'm sure Brandon will follow up. But Mina's a zk native blockchain. So what does that mean? It means that like any interaction that happens on the blockchain, be it a transfer of Mina, be it staking, delegation, and then, in the upcoming smart contract platform, any state change, instead of those things being like executed in a VM, they are represented as a zero knowledge proof. And that's what the Mina validators are doing. They're verifying these proofs incredibly efficiently and also representing that in this famously succinct 22 kilobyte proof with which you're able to prove the entire Mina blockchain. So it's very, certainly novel in being mainnet when ZK was, really just getting started. And, we'll talk more about like why it's going to be such a solid foundation for zkApps. But that's how I would describe Mina today.
Cool.
Brandon?
Yeah, I think you hit the nail on the head. The one thing that I would expand on, I suppose, is this succinctness. It's powered by recursive proofs. And this kind of recursive proof power is what makes Mina special. This recursion power is a very important component in the tools that we build, both in Mina and surrounding it.
Yeah, because we led into this with why why Mina, like, that was part of when I was looking out there in the crypto world, like why Mina? There's actually a very compelling reason from my perspective, who was wanting to take their passion and make it their full-time role. And, one of those things, often when we talk about Mina, it's like, okay, the succinctness is cool and it's super cool technology, but what does it enable? And this is one thing that I get so excited about. I don't know if it's always obvious, but you've heard of Vitalik talking about the sci-fi future of Ethereum, where it's download a couple of snarks and you're on the canonical chain. Like, that's Mina today, right? And so that's why when I was like getting excited about, okay, what's my little piece of the crypto world? Like, where am I going to join in? This idea that you could have a blockchain that you can verify in the browser, that you can send proofs to without an API owned by some company, without everything being in the clear. Like, Mina is a lot about what Web3 can really be. And so, it's not just the coolness of the technology.
So you were just saying that it was like, it is that sort of future. That's cool. Sort of moving on from Mina as the underlying infrastructure, I want to start talking a little bit more about zkApps, or what used to be called snaps. And one of the reasons for this is I want to just kind of check to see if I understand them as the same thing. And what are they today? What kind of do you imagine it being? So, Brendan, can you tell us a little bit the history of zkApps and what they are?
So zkApps are what we call dApps on Mina. And yes, they used to be called snaps. What they are, they're in some ways a superset of what you can do with typical dApps. So you can do the sorts of things you can do with dApps, but you can also leverage privacy. And the way this works, or sort of what is at the core of the smart contract platform, and this idea that execution of the application happens client-side. So execution happens client-side, typically on the user's machine in their web browser. And so private data never leaves their custody. And then a proof that certifies that such execution happened properly, that's what gets sent to Mina. And that gets recursively composed, recursively folded in, recursively proven into that one tiny Mina succinct proof.
So the word sort of snaps or zkApps both sound like a plural of something, but what it actually is like a platform, right? It's like an environment where one can deploy these things. Or do you have a different name for that?
Yeah. I suppose nomenclature, and Steve can jump in if you disagree with anything, but like, I think sometimes we say like the zkApp platform, and then the zkApp is one such instance of an application, kind of similar to how you would say in the EVM, I don't know, do you say that a dApp platform or
the smart contract environment?
Yeah, I think you got it, Brandon, with it's a ZK-enabled smart contract platform, right? We build zkApps using o1js, which is, we'll talk about that as the SDK. And you build smart contracts, and then instead of them executing in a VM, like in the EVM, they execute in your browser, you generate a proof, and it's that proof that gets settled to the blockchain. So it's a smart contract platform with the secret sauce of ZK, meaning privacy. You can choose what inputs are private. Like Brandon said, data stays on the machine. It's really, I think, realizing the vision of Web3, smart contracts.
And there is this confusion, I think, with nomenclature here that I want to contribute to. I think there's a distinction between smart contract and dApp that in some ways, I guess, we inherit. So there's the smart contract, which is the actual thing that is running either on the chain in a typical platform or in the user's browser, in this case, in a zero-knowledge proof. But the actual application that surrounds it has a user interface and is like the full package. So in that sense, like, I think what we've built is not just a smart contract platform, but the surrounding package, I think, serves this greater purpose of building these applications in a web context.
I want to sort of understand if, like, Steve, what you had said is you can have sort of like an application running and then just does that last proof. But what this makes me think is that there's sort of a separate execution environment that's then tied into the Mina blockchain. This is what I want to kind of understand if my thinking is correct there. So, like, and what is that environment then?
Yeah, let's compare. Maybe we'll compare with sort of what people know today. Like, so say you build a dApp on Ethereum and you have some React front end. You click a button, that button builds like an HTTPS request that goes to some centralized gateway that turns it into an Ethereum transaction. It goes into the mempool on the blockchain. Some validator sees it, executes it in the EVM. So there's the execution context in that case, right? It's a validator. And then, there's some state change that represents that. That's the flow most of us are sort of familiar with. Okay, so what's the zkApp version? So again, you might have a React front end. Nothing changes. You got a button, right? But now when you click the button, What executes is the proving function. So literally some JavaScript code in the browser. So the browser is the execution environment. All of the inputs to that, the user's, private data, whatever else, stayed on their machine, ran this, well, I said JavaScript, but, WASM, all right, code, generates the proof, and it's that proof that then goes to the blockchain to be verified. So it's not executed by the validators, it's just verified by the validators. And that's where so much of the goodness comes from, right? That it's, it's cheaper. Like it's very cheap to verify a proof compared to like executing. The data didn't have to leave the machine. Yeah, it's fundamentally different. And it's kind of exciting because if you think about it now, in every single browser in the world becomes a potential execution client for zkApps.
Is the zkP or the proof in this case then a proof of validity that what's happened in the browser is what they've said happened in the browser in some way?
That's a good question. When you say proof of validity, I think what I'm hearing is validity proof, and that has a kind of specific meaning in the like optimistic and zk rollup sort of world.
Yeah.
So, but I would say in a general sense, the answer is yes. Like you are able to prove that this state transition is valid, that, you had knowledge of a private key and, you executed a function faithfully, correctly, nothing was changed. You couldn't possibly have produced this proof of the state transition without this knowledge. And so in that sense, yes, you're proving that this state change is valid.
Another question though, if your execution environment is your browser, then is there no global execution environment? Like, is there no shared execution?
Well, one way to think about it is it's the only global execution environment because the execution actually happens on, or is capable of happening on sort of the vast array of consumer machines that exist in the world. But the second part, there's a very interesting relationship with sharing computation, sharing state in applications in this platform. And there's a lot of different ways you can do it that solve different problems. It's an interesting challenge in this environment for sure.
Is it something that like you would decide as an app developer how shared it is and where it's shared somehow? Is that sort of what you mean?
Yeah. So for example, if you want to share computation, then you can use recursion. You can use recursive proofs. So you can have one user do one sort of step of a game, another user doing the next step of the game, and then a third user that takes the recursive combination of that and sends it to the chain, for example.
Wow.
If you want to share state, you can use Mina. So you can write something to Mina, and then another, later contract can read that information. There's this issue that comes up when you do client-side computation of the data races, or this problem where if two users are trying to access the same state at the same time, then and change it in different ways, then there might be some sort of conflict. And one mechanism we have for managing that is something called the action and reducer system, which is very similar to a similar state management system in React. I guess to answer your question, yes, the developer decides, and the developer decides amongst a lot of really interesting mechanisms that are unique and different from what developers are used to. So we definitely spend a lot of effort on education around those pieces.
Yeah, can I add to that? Because I think the reason you're asking for the right reason, Anna, because it's a different mental model, right? It's like, well, if the execution is happening over here, so what then? And this is one of the things when developers first come to zk, like there's this sort of mind shift that has to happen in terms of like how you do things, and so we try to reduce that as much as possible. And I'm sure we'll talk a bunch about o1js, but that's why being able to write zkApps in TypeScript, right? It means, okay, at least I'm not having to learn a new language. But in this specific example as well, like Brandon said, there's a actions and reducers framework. So that's something that a lot of web developers are familiar with if they've used React. And that's what we try to do with o1js is like actually provide useful abstractions, right? Not just say, okay, you can build a circuit, when the obvious next question sometimes is like, what's a circuit? Like, when people are just starting out, right? So having these sort of abstractions is super critical, I think, to zk as an industry. I think the industry has a ways to go, but it's something that, we definitely spend a lot of time on.
And we've even changed most of the references to circuit to provable in our tools, because the term circuit is we believe is like an unnecessary implementation detail of the thing that you're trying to do, which is to prove something.
And it also has a certain mental model when you say it, when you say circuit, like something,
right?
At least for the layman, but I also think for people who aren't deep in it, right? Like there's an electric circuit, there's like a circuit tree, there's like something, some connotation that it has in how you'd interface with it.
Yeah, it goes further than that. That's what I have. I have this mental model of a like PCB board, right? Like with lines and transistors and stuff.
Me too.
And when you use some of the lower level zk languages, like it's kind of not that different. Like it's pretty low level. Yeah. Whereas when you're writing zkApps, like it's more like Merkle tree dot add, or like I'll embarrass myself if I go too far in, but it's like abstractions and data structures that most developers are a little more familiar with.
Yeah.
And circuits are the implementation detail that is true today. But, maybe someday there's we're going to change our proof systems to have some other strange way of executing under the hood. How we think about computation at the level of designing applications shouldn't change. And so coupling ourselves to the terminology of circuit there is perhaps a mistake.
So, I mean, just to paraphrase what we just talked about, but it's the idea that to interface with this, you will have to think a little bit different on how you design the architecture of an app almost, and the things that are possible, how you maybe deploy it, or some of the decision making that goes as you do it. You kind of coupled that with o1js, which we want to talk about, I think we should talk about right after this, which is meant to simplify that language part, which I know a lot of teams have designed their own languages that create kind of that extra learning curve, that extra step. First, you have to learn the language, then you have to potentially learn the new architectures. Yeah. Let's talk about o1js. That used to also have another name, which we might have mentioned on a previous episode. So everything used to have snark or SN at the beginning of it. So a snaps, snarkitecture. I think there was like a snarkosaurus or something at some point. There was a Frankensnark. There's a lot of things that Isaac and I back in the day on previous episodes chatted about. So we just mentioned Snaps has been rebranded to zkApps, and SnarkyJS has been rebranded to o1js. But let's talk about what that is.
Yeah. So o1js, it's a TypeScript library and embedded DSL for writing zero-knowledge enabled smart contracts based on snarks. There's a fair bit packed in there, but I think it covers the main things, and I'll maybe just break it down a little. So it's a TypeScript library. And so literally to get started with o1js and writing zkApps is npm install o1labs/o1js. The embedded DSL part, I think, is kind of important because, like we talked about, some, projects require you to learn a new language. And so you sort of, one, have the mental load of a new language, and you're taking a bet, I guess, on a project's longevity. We've really gone to great efforts to stick with TypeScript as the language. But I think it's important to acknowledge, you still need to call out when you write a zero-knowledge enabled smart contract, which parts of the code are the provable parts, right? Which is the part that, is going to represent the state chain on the blockchain. And so there is a DSL for that, but instead of it being some weird and wonderful thing, like Brandon said, it's provable dot, add, provable dot check, or it's a very natural sort of TypeScript language. And then, at the end, what you get? You get a snark. And that's what settles to the blockchain.
And I think it's important to call out, there's a lot of dimensions upon which you can categorize different ZK DSLs and programming languages. And I could talk about it for hours. So I'll have to, force myself to be concise. But I think one important dimension here that makes o1js sort of different from a lot of other ZK languages and tools these days is when you're describing a proof with o1js, you're not describing a program that runs then later in a ZK VM of, either like Miden or RISC-Zero's VM or any of that. You're actually describing the circuit. That's the implementation detail, but you're describing the proof. And so you need some DSL features, as Steve was talking about. But we've gone to great lengths to ensure that it's as smooth as possible to interact with. And importantly, the DSL being embedded is a big thing.
I actually don't know what you mean by embedded DSL.
Yes.
What is that?
Let's talk about it. So a DSL is embedded inside a host language if it is basically represented as a library in that host. So I'll give an example. React.js. Well, that's a complicated example. jQuery, for those that are familiar, jQuery is this old web framework from like the early 2000s. jQuery is an embedded DSL in JavaScript. So it's a JavaScript library that it feels like a different language, but it's JavaScript. Like it's defined in JavaScript. You're writing JavaScript when you write jQuery.
Yeah.
And then in contrast, an external DSL or a DSL that is not embedded inside of a host language, for example, is HTML. So when you write HTML, like you're in the HTML language, but it's a DSL, it's a domain-specific language for describing the content of a web page, for example. But the issue with external DSLs in general, and in my opinion, always, is that when you're focused on one specific domain, you end up missing important general purpose language features that developers actually need to do things, to do anything productively. So you end up having loops, conditionals, functions, abstraction, modules. All these things end up being shitty. Can I say that? they end up being annoying, very, very annoying, very frustrating. As a developer, I can't stand when I'm forced to use an external DSL. I literally struggle to think of a time in any context, not just ZK, literally in any context where I say to myself, oh, thank God I have this external DSL instead of a DSL embedded in a host language that is general purpose, that can do useful things. So in this case, like o1js is embedded in TypeScript because these days developers like to build applications in the web platform. In o1js, we have function abstraction, we have types, we have structures. You're able to go down to the specific lowest level pieces when you need to optimize something, but you're able to hide that, building up like different kinds of abstractions. But the most important thing about the way that we do it in o1js, and the most important thing that every DSL author should be thinking about when they're deciding to build these kinds of systems, is you want to leverage the knowledge of the developer and the hundreds of millions of, maybe that's an exaggeration, but the hundreds of millions of hours that developers have put into these general purpose tools. Like God knows how much effort has been put into TypeScript and JavaScript in the ecosystem. And why would you throw that out? It's crazy. It's crazy to me. Everyone who's building a new language from scratch, they not only have to solve their problem of like building this ZK DSL in a way that's usable for developers, like just making them understand ZK. That's already hard. But then they also need to build package managers, abstraction systems,
build systems,
systems, package managers. Did I say that? It's just inevitable that you'll end up with a system that's more cumbersome to use. So that's my rant.
I would just say from a product point of view, it comes like I agree with everything Brandon said. It's that you want to have a great developer experience, which means for us, not learning a new language, right? That you can use TypeScript, that you've got all of your tools set up, like you work in Visual Studio Code, right? So you just want to npm install, like choose your UI framework, React, Vue.js, right? Like write your zkApps, start calling, functions on it. Like that's the experience you want. You don't want the what's this new language and how do I design a circuit and like these things that should be implementation details. That's one thing I love about o1js. As is the privacy part. I'm sure we'll dive into sort of the magic of ZK, right, is being able to like have, these private inputs and like being able to just declare that when you're writing TypeScript. Like, I think that's the sort of magical developer experience that's going to actually unlock ZK to the masses. Cause I don't think we're there yet.
Yeah. I mean, I think that's been like a big topic actually in our community recently. I mean, for a while, but really like recently I'm seeing more and more talks focus on this, more and more kind of thinkers in the space highlighting it, which is where are the use cases? Where are these builds? Where are these, uses for the cool properties that zero knowledge offers? But my rebuttal to that so far has been a little bit, it's so hard to build these things that level of experimentation could only be theoretic. Like you could imagine use cases, but you couldn't actually like create usable versions of those use cases for a long while.
Before we go into the use cases, I just want to sort of address one thing that you just said, Anna, about how it's been difficult. Like perhaps it's been difficult to leverage the features. And I just want to sort of say my take on this. What we see a lot of is like two different, really far away iterations on zk. So there's deep on the proof system side, like there's all this interesting stuff with proof systems that can do all these wild and crazy things, but they're so hard. It's so hard to actually leverage that because you have to have, a PhD to tinker with that stuff. And then on the other side, there are some nice tools that work with zk VMs, but then the VM sucks up all the interesting parts of the proof system, and you're left with this interface where you can build the normal application that you can do on any platform.
Yeah.
So what we're building is this thing in between where we take the deep, awesome, intense proof system stuff. We package it up in this context that lets you use it with recursion. And we take this important, very important focus on building a usable developer environment, and we put those things together. And so we hope that with these tools, perhaps, we'll see some really interesting use cases, which Steve is about to go deep into, I think.
Cool.
Yeah. So yeah, you were saying, Anna, like, it's this topic of like, where are the use cases, and especially ones that leverage privacy, given that's part of the magic of zk. And like, I think about this a lot, and I think it's a good question because I would argue that at the moment, definitely the majority of like time and capital and coverage that's being deployed in zk isn't leveraging privacy. It's in the verifiable compute part. And so here I'm thinking, zk rollups, basically scaling execution, especially on Ethereum, but increasingly other types of execution as well. And even we see this at o1 Labs, like we're working, with Optimism to provide zero knowledge proofs of their fault proof program, right? So even us, the sort of like zk OGs who, are all into the privacy aspects as well, like it's irrefutable, I think, that just the verifiable compute aspect of zk is powerful on its own, even without privacy. But with privacy, it sort of then it feels like it should go from compelling and important to magical. So where is it? And I think this is where I agree with Brandon. Some of it is just that the developer experience has been so difficult to architect an application that, really maintains privacy. And again, one good thing, o1js, and, the private execution environment we're talking about. But I am, I spend all day on use cases, right? And I see them coming now. And like, I'll share a couple if you want to hear.
Yes.
So one team I've worked with a lot is Snickerdoodle, and they're a Web3 advertising platform. And it's funny because you'd think, what? Like, advertising? No, that's so Web 2. But it's advertising in the Web 3 way, which is that you can consent to being advertised to, and you can consent to sharing some details about yourself. And so that could be something like, my wallet regularly trades DeFi, or I have owned Ethereum since 2015, right? And those are attributes that a Web3 advertiser would really want to know. But instead of, giving up your email address, your phone number, or being tracked all over the web, you just provide a zero knowledge proof of those things. And the advertiser can verify, like, okay, I have cryptographic proof that, this wallet has these attributes, and that's valuable enough to me to advertise to and maybe even share rewards with. But it's put into a sort of pool that means that I'm not individually trackable. Right. Mm-hmm. So it's this sort of beautiful symbiotic relationship of like, I will share some amount of data that is useful to an advertiser to get like something in return, but I don't get tracked all over the internet. And so this is actually the privacy part. Right. And I love that one.
That's cool. Although I don't really understand how you advertise to an address.
Yeah.
You can airdrop the address, I guess, but like.
So the team, that team, they're still working out what the best like rewards sort of models are. Like, is it that if you share a certain amount of data, like you get sort of digital rewards, or I think that part there's still some work to do. But it's cool, and it's actually privacy with the sort of verification aspects. I'll give you another one. I just learned about this one the other day. I can be a bit skeptical of grand claims with use cases sometimes. And while I'm watching zkML space with a lot of interest, like the sort of, that we will prove every inference or will prove every training data of like the largest models. Yeah, like not so into that. But there is a team that's in the zk Ignite program, which is Mina's like builder program, called Biosnark. and they do drug development, right? And this is one of those ones where it's specific enough to be useful, but like really good fit for the technology, which is when you build a drug, you want to prove that with some sort of input, this molecular structure that you've developed has some attribute at the end. And that's, like whatever, whether it's defending against something, attacking something, like whatever else. But you could have spent hundreds of millions of dollars to develop that model. And so if you're trying to sell it to a big drug company, what do? Do you just hand it over and hope they don't take it? Do you give it to a broker? And these things exist, but there are data brokers, there are platforms, but it's ad hoc, it's expensive, it's risky. And so this team have built like they call it a scoring function to be able to represent this molecular structure in zero knowledge to prove that when a given input comes in, you get some output that gives you confidence it can have this desired effect.
Cool.
Yeah. So they're coming. I just want to say that like the privacy use cases are coming.
I mean, that one's very, very, very like domain specific, but I think the concept that it's outlining, just the proving something under the hood. I mean, we've heard that about like code. We've heard, that's like one of the use cases we've heard a lot about, being able to prove that something's happening in a private environment correctly.
Yeah.
Yeah. That's really cool.
I love domain specific ones. I think those are the ones where like the technology gets its foothold, right? And then people start to like latch onto that and be like, oh, how can I apply that to my industry, right? Yeah. Rather than the other way around where it's this, everything can be private. Everything can be verifiable. It's like, oh, what do I do with that?
Solutions without a problem. That felt a little bit like, or tools without a place to use them. Like, look at this cool thing. It does this. I think this is where we're at right now as an industry, right? We're just getting into that moment where we can start to like apply these things to real world things, to real world cases.
Yep.
I think in the past, it was, like you said, Brendan, and actually Steve, just the fact that it was so hard to build anything. Like the product people tended to be the applied cryptographers who are not necessarily thinking about products as much as they're thinking about implementing efficiently. And yet they were the ones coming up with products because they were the only ones who could really use the tools.
Yeah.
Like right now, as we speak, I think the door is kind of opening to a lot more product folks like yourself, Steve, actually.
Yeah.
To get in and start thinking about this stuff.
Yeah. And like an example with that Snickerdoodle one, part of that system is like, besides what I described, there's also like making sure you don't get double counting, which is a common thing in zk. You want to prove that you haven't already, because you don't know who like the individual is providing the data, you need to make sure that you're not getting double submissions, like a bot, for example, clicking on a web page, right? So one of the things they had to do was like they call it a nullifier, but it was basically like checking something exists in a Merkle tree. Let's just say that. And they tried a couple of different frameworks to implement that. And it was sort of 30 to 100 lines in the other frameworks, 3 lines in o1js, because it's literally, there's the right data structure and you're just checking. And so, yeah, when that's the developer experience of like, working with abstract data types, just writing code versus designing circuits by hand that, hundreds of lines. That's why I think these use cases are starting to emerge now.
So I want to bring it back to o1js and zkApps and like the zkApps platform. Where are we at with that? Can people already use it? I know that there's been a lot of test nets. I sort of want to understand the state of both of those things. And is there anything left to build?
Yeah, great question. I'll start. So o1js is in production today. You can npm install, start building applications that, generate zero knowledge proofs in the browser. You can even build production like off-chain applications where, apps interact peer-to-peer, verifying proofs. So usable today. That's the first one. For zkApps, yeah, that relies on the next hard fork of the Mina protocol. Should the community vote for it, which we're very confident they will. They're certainly excited about it. Yeah, you asked about testnets. So there's been multiple testnets running for over 2 years now, right, Brandon? Is that over 2 years testnet for zkApps? Yeah. But what's just changed and what's exciting is, the incentivized testnet has just kicked off. So we have a bunch of, ecosystem partners running validators, like running tools, sort of load testing, performance testing, trying to break it. Right, like this is the sort of candidate release for the zkApps release of the Mina protocol. So, yeah, it's a good time to be talking about it. Yeah.
The reason I actually ask this is
Yeah.
I think last time when I talked to Izzy about this, it was 2 years ago. And on that show, he was like, it's coming really soon. And then when I was listening to that, I was like, wait, what came? But it sounds like the testnets did come. It's just you stayed in sort of testnet phase for a pretty long time. Can you say why?
Yeah, I think it's safe to say we underestimated the effort it would take to stabilize such a large change. I think it has been very hard for us to estimate how long large pieces of work like this in the ZK space take. But yes, we did get our testnet out. We had a lot of bugs. We fixed a lot of bugs. We believe we have something very stable, much more stable than when we did the incentivized testnet for Mina mainnet. We're in a much better place, like comparatively.
Nice.
But yeah, as things go in this space, it took a little longer than we expected.
Mm-hmm.
Yeah, I think too, like it's clearly an industry thing, right? Like most ZK platforms have sort of taken longer than they expect. And the reality is too, even in those 2 years, Anna, like the amount of economic value that blockchains secure, all blockchains, has increased a lot. And so the sort of level of internal scrutiny, external scrutiny, like the level of confidence, like I think required just goes up and up. So I'm definitely glad the team took the time that they did.
I don't think anyone's annoyed that you're not YOLOing into zkApps. I think it's really good if they're good, if the platform is stable. I do feel like you've had a bit of a head start because you were sort of deploying this stuff quite early. You had people already building on it earlier than anyone else. At the same time, there are some other teams coming out with stuff. So do you see a mainnet? I don't even know if I should ask, but do you see a mainnet in the next few months? Or do you think it's going to remain in sort of this testnet land for a little longer? It's almost like, how should people approach it? Should they think about it like, this is a great playground? Or should they be like, this is where I could build my company?
This is where I could build my company. It's coming in hot. Like the incentivized test network, is the last testnet before the community will vote on hard forking in zkApps. Like, yeah, as we discussed, you talked 2 years ago about when the date is. So like, yeah, is it, this month or that month? It's hard to get down to the month. But if you had asked me the question in the next few months, yes, like it's coming.
Cool. Okay. Well, this is very exciting. I feel like in the ZK space, there's a lot of very interesting new architecture ideas, or like almost ways that ZK will enable like new environments to lock into other environments. I know in the past you've done work on bridging. Brendan, I know you and I have had a chat about like DA and how Mina has it or not, like how it's kind of understood in the Mina context. There's like an increasing group of teams that are like looking at this co-processor role. And I do wonder, how does Mina fit into that world?
So I first heard about ZK processors on this show, Anna. I think it was Axiom describing like their ability to provide proofs of historical Ethereum data, for applications, which I thought was cool. But I thought what even was cooler was the introduction of this term, the ZK coprocessor. And that got me thinking. And while it's cool, it's extremely limiting. If you think about what coprocessor like meant historically, right? It's offloading execution from a CPU to some other chip. Like, so a million years ago, like an ALU, something optimized for arithmetic circuits. And, that was a huge step change in CPU design to be able to like offload these things. And now we see it in GPUs, et cetera. And so I think calling a coprocessor like something that proves historical data is kind of limiting. Whereas in the Mina context, right, we've just made, in the o1js context, we've just made every browser in the world a ZK coprocessor, because now the computing power of every device is available to generate these proofs, and it's those proofs that they're going to settle to Mina. So if you think about Mina as the global computer, then every single browser in the world out there is a ZK processor, and that's cool.
Oh, wow.
So when I think about sort of interesting ZK architecture concepts that maybe haven't been explored enough, especially when applied to Mina, I really just keep going back to recursion. Recursion's at the heart of everything. So I guess like we did talk about a few specific interesting use cases. I think like more generally, all these use case categories that people talk about with ZK, like identity, voting, games, zkML even, like identity when you add recursion, you can compose attestations together. With voting, when you add recursion, you get interesting forms of scaling. With gaming, when you add recursion, you get multiplayer, peer-to-peer, trustless communication with sort of anti-cheat filters built in. With zkML, when you add recursion, you get incremental updating of data sets if you lay out your data in recursive proof trees. I'm just so excited to see, what people do with recursion.
So I think we've reached basically the end of the episode, but I do think we're in this, and we've already said it a little bit before, but I think we're in this really interesting moment where these new platforms are going to come online. There's going to be more developers actually able to experiment. If people are interested today, what do they do? How do they get involved? Yeah. And is there anything maybe you want to tell folks who might be like just on the cusp of jumping in, but like are still kind of nervous?
Yeah, I start with the code. Google o1js, npm install, get started. There's lots of docs, lots of examples, super active and super supportive Discord community. There's Q&A, there's, folks just hanging out. You can run ideas by. There's folks from both O1 Labs there. There's folks from the Mina Foundation there. And yeah, like if you've been intimidated maybe by the technology, right? And this idea of like, what on earth is zk and like, how do I write a circuit? But the concept of like decentralized apps with privacy that you can build using TypeScript and all the libraries, all the tooling, in Visual Studio Code, like, yeah, install and get building.
Nice.
And, there are also programs run by Mina Foundation to sort of help developers get started and to give some structured grant programs and things like this. There's zk Ignite, which is a builder program that runs in cohorts where members of the community vote on projects to get funding. So you can work through that. There's a new Mina Navigators program where you can work on sort of larger projects and get perpetual funding through that as well. And I'm sure there's others.
And actually, there's more and more hackathons focused on zk.
Yes.
I might be doing some of those as well. So hopefully we'll be seeing o1 Labs and the Mina team over there for those future events.
Absolutely.
So thank you to both of you for coming on the show and sharing with us all of this info and the updates about zkApps and o1js and kind of where the project's at. Yeah, thanks so much.
Thanks for having us, Anna. Big fan of the show, so really enjoyed jumping on.
Cool.
Yeah, thank you so much.
I want to say a big thank you to the podcast team, Henrik, Rachel, and Tanya, and to our listeners. Thanks for listening.